To my channel SPS Physics Classes by S. Fanindra Sharma. Today, let us see the interesting problem over the continuous mass distribution of objects. Let us see. Let us explore the concept of center of mass of something like a wire. Let us try to explore the possibilities in the given system. Now, if you consider any wire such a way that in the first observation process, we would like to take a semicircular wire like this. This is the x-axis and as well as y-axis. Over the x-axis and y-axis, I am imagining that there is a wire which is held in the form of a semicircular like this shape. Now, for this particular wire, the linear mass density of the wire is nothing but a constant quantity. Linear mass density means what? Mass per unit length of the wire. What is the mass of object M? Total length of the wire is equal to radius into angle at the center, nothing but lambda, which is equal to, say, it is some constant value. Now, this is also equal to dm by dl. When I consider a smallest hyperfine elemental length of dl, that dl contains mass of dm, that also contains the same lambda. Therefore, the value of mass of the element dm given by try to multiply this entire thing m by r pi into dl. So, when you try to consider a smallest portional element d theta at the center angle and radius is r. In that situation, when you try to plot the foot of perpendiculars to the observation point, then here angle is theta degrees. From here to here, we have a distance of small x, and from here to here, distance of small y. Now substitute the values of dl in the equation, which is called as m by r pi. dl is nothing but you can write down as radius into angle at the center. Therefore, rr gets cancelled. You can write down as dm is equal to m by pi into d theta. Now, we got the value of mass of that particular element. Further, when you consider the x coordinate and y coordinate, the value of x from the figure, let r be the radius statistic, then the value of x is equal to, you can write down as r cos theta, and the value of y is equal to, you can write down as r sin theta. We can write down like this. No doubt that is, these particular x and y represents the position of the point where we imagined in the given problem. Now, let us try to apply the concept of center of mass for the continuously distributed mass cases. Let us consider, first of all, position of xcm. So, the xcom, x position of center of mass, is equal to integration of x dm divided by integration of dm. This is the formula for the position of center of mass. Under such a condition, when you substitute the value of dm and x from the x and as well as dm, we get an equation that is integration r cos theta into m by pi d theta running over limits 0 to pi, and denominator also 0 to pi. Upon substitution, we have m by pi into d theta. We can write down like this. Now in the given problem, one can cancel no doubt the terms m by pi and m by pi because they are constant numbers, one can cancel. Further, if you prepare remaining answers, r by pi integration of cos theta d theta running from limits 0 to pi. Upon again substituting or doing the integration value, we get r by pi of sin theta running over limits 0 to pi. This value becomes 0. Therefore, position of center of mass will becomes what? 0 in the given problem. Now, let us try to work out for the y coordinate, y COM. When you consider y COM, the value of y COM is given by same to same formula, integration of y dm divided by integration of dm we have to write down. Upon substituting the values of y and dm from our previous result, y is equal to r sin theta, we have integration r sin theta into m by pi d theta divided by integration of m by pi d theta, we can write down like this. Now one can cancel the terms according to our observation as m by pi and m by pi. Then we have the value of r by pi because the limits are running from 0 to pi here and 0 to pi are the limits. And the remaining answer is integration 0 to pi sin theta into d theta. When you solve for these, we have r by pi of sin theta integration is minus cos theta, which are running from the limits 0 to pi. Upon substituting limits, we can write down as 2r by pi. So therefore, the entire position of center of mass of this particular wire, x coordinate is 0, that means x coordinate is 0, and y coordinate will be at this particular location approximately. Now this is called as center of mass. So this particular height, okay, that is how much we have, 2r by pi. That is the respective answer. Now when you consider the position coordinate called as rc bar is equal to xci plus ycj, we can write down. Xc is nothing but how much we got, 0. Therefore we can write down as 2r by pi into j cap, we can write down. This is the right answer for the solution.